Welcome to my classroom. We learn circles in Form 5 and know how to determine whether 4 points are concyclic or not. In this video, I will talk about a challenging problem of concyclic points on 5 circles. So, this video is for able students who have a good understanding on circles and want to get a taste of challenging problem of circles. Here is the problem. A to E are the tips of a 5-point star. F to J are the intersection points of the sides. As 3 non-collinear points can determine the circle, a circle is formed by AFJ. In this way, 5 circles are constructed. In the diagram, we see that F to J are the inner intersection points of the circles, and P to T are the external intersection points of the circles. The problem is to prove that these 5 points P to T are concyclic. I suppose you need more time to observe and figure out the solution, so you may stop the video and take time for the challenge. In Form 5, we learned the conditions for determining whether 4 points are concyclic. If we can prove 4 points, say P, Q, R, S are concyclic, due to symmetry, or use the same argument, we can also prove Q, R, S, T are concyclic. As the 3 points Q, R, S are in common, which can determine a unique circle. So, the first circle defined by P, Q, R, S is same as the second circle defined by Q, R, S, T. That is, the 5 points P to T are concyclic. In other words, the problem is equivalent to prove 4 points P to S are concyclic. There are 2 main parts in the solution. The first part is to lay a foundation for the second part. In the first part, we first solve 4 points A, P, G, D are concyclic. For the cyclic quadrilateral APFJ, angle PAJ, that is angle PAD, equals angle PFB. They are opposite angles cyclic quadrilateral. For circle BFG, angle PFB equals angle PGB. They are angles in the same segment. Combine the results, we have angle PAD equals angle PGB. Thus, APGD are concyclic. Exterior angle equals interior opposite angle. Due to symmetry, AGRD are also concyclic. In these 2 circles, there are 3 points A, G, and D in common. That means the 2 circles are the same circle. That is, A, P, G, R, D are concyclic. Due to symmetry again, we have another 5 points. B, Q, H, S, E are concyclic. Now, the second part is to prove 4 points P, Q, R, S are concyclic. We are going to use converse of angles in the same segment to prove this. And we split the angles into 2 parts and use the result in the first part to achieve this. In circle BFG, angle QPG equals angle QBG. The reason is angles in the same segment. Since BQHSE are concyclic, the yellow one, angle QBG or angle QBH equals angle QSH. They are angles in the same segment. Combine the results, we have angle QPG equals angle QSH. In circle DHI, angle RSH equals to angle RDH. They are angles in the same segment. Since APGLD are concyclic, the blue one, angle LDH, that is angle LDG, equals angle LPG. They are angles in the same segment. That is angle LSH equals angle LPG. Combine the angles, we have angle QPR equals angle RSQ. By the converse of angles in the same segment, the 4 points PQRS are concyclic. Due to symmetry, the 4 points QRST are also concyclic. As QRS are in common, we have 5 points PQRST are concyclic. The proof is done. So, the statement is proved by using the simple properties that we learned in Form 5. But I suppose you agree with me that it is a challenging problem that involves a complicated diagram and requires a clear mind for observation. Actually, I found this problem in a newspaper in 2000. The problem was given by the President Concyclic, who visited Macau then. Some reporters contact Mr. Jasper Zhang Yuxing afterwards for a solution. Both the problem and solution will appear in newspapers on the next day. You may see that President Jiang and Mr. Zhang are fond of geometry, and Mr. Zhang is an excellent problem solver, particularly in geometry. I hope you enjoyed the challenge too.